Okay, so I want to show you how to do the three simulations you're going to do today using your calculator to kind of drive the simulations. The problem is a very famous problem that most people misestimate. So the first thing you're going to do is try to estimate this number. If you're not clear on the question, make sure you verify. But the question goes like this. How many people ought we have in a room so that we have a better than 50% chance that two people have the same birthday? Okay, so what that means is that if we were going to, if we had this many people in a room, like, let's say the number is 50, okay? We have 50 people in the room. If there's a 50% chance that two people have the same birthday, then every time we have 50 people in the room, half of the time two people won't have a matching birthday, and the other half of the time you'll have at least one matching birthday. So more than one matching birthday doesn't matter either. So it's just at least one. So the first thing to do is estimate that. So one of the approaches that I like to take to this is using the random number generator on the calculator. So think about that number. How many people do you think there should be in a room so that if we went to a room with that many people many, many times, about half of those rooms would have two people with the same birthday. And by same birthday, I mean, April 13th. Okay, it doesn't have to be the same year, but same day. So you can use your calculator, same key that we've been going to in this chapter for probability. We go to the probability key. We've been using permutations and combinations, but we're going to come over here to this random key. This is pretty cool. So you have number 2, the random integer generator. Okay, I'm going to click on 2 or just press enter there, arrow down to it. So what I'm going to tell the calculator to do is generate random numbers. So you have to put in 1, and then you're going to need to get this comma key. The way you get the comma key is by hitting the second key and then the decimal. See that comma in gray? So I want to say second and the comma, and I'm going to need that again in a second. I'm going to tell the calculator to give me random integers that live between 1 and 365. Now later on we can tell it to give us a bunch of them. I'm just going to do it one at a time because the way I approach this problem when I teach it, it can be very complicated to calculate directly, but the way I try to picture it is, suppose we have two people in the room, what's the probability that their birthday matches? Well, it's only 1 out of 365. So instead of doing the probability that their birthdays match, I do the probability that they don't match. And then I have another person come into the room and another person. So that's what I want to kind of simulate here. I'm just going to keep pressing enter. I'm going to execute this command. So there's somebody born on day 352. I don't know what month and day that is, but it's the 352nd day of the year, probably somewhere in December, right? So I'm going to write that down. So you're going to execute that command and you write that number down and try to keep them sorted. And then I got 302. The better you can keep these sorted, the better you'll be able to find a match. I'm going to press enter again. This time I got 356. It looks like I got another 351, so a bunch of people born close to the same date. Then I get 189. So I try to keep those numbers away from each other. I got 85. Try to keep numbers like in the same groups of hundreds near each other. There's January 2nd birthday. And then we got 208. Fish him in here. So I'm just writing these down on my whiteboard. 119. So now at this point I'm up to 1, 2, 3, 4, 5, 6, 7, 8, 9 people in the room, and I have not had a matching birthday yet. I'm going to keep looking for it. 203, still not a match. So what I'm doing, you can see my whiteboard, I'm writing the numbers in the same hundreds groups next to each other. That'll help me to be able to identify a match more easily. We got our match, 85. Okay, so what we found here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So we're just adding people to the room, and by the time we got to the 12th person, we had a matching birthday. So I want everybody in your team, to run this simulation and compare your results. How many people did it take to enter the room until you had a matching birthday? Discuss your results. And then if you want to change your estimate that you started with, you can change it at that point. Okay? The second two simulations are virtually the same thing. They're very similar. What we're going to do with the second simulation is I'm going to say, what's the probability that if we have 20 people in the room, we'll just up the ante to 20 people. Let's have 20 people in the room, and let's see how often we get a matching birthday. So the way we can do this is same thing with the probability key. We go over to random, and we select number 2, random integer. So I do almost the same thing, second, comma, we go 3, 6, 5. We're going to hit that comma again, and we're going to say, give us 20 numbers. So basically, this is just going to right away, straight away, it's going to give us 20 people in the room. Okay. So as soon as we'll look at the birthdays and see if we can find a match. Okay, so it looks like the calculator does not function the same way I expected it to, the way the graphing calculator does. So the way you'll run this simulation, and your worksheet should have you set up so that it can be organized. I want you to do it 10 times. Okay, so what you're going to do is you're going to have 10 different groups of 20. All right, everybody in your team is going to do 10 different groups of 20. And what we'll do is, so we go random integer, 1, 365. Oops, missed my comma. So we'll do it just like we did the first one, except we're not going to press enter until 2 birthdays match. We're definitely going to press enter 20 times, and I want you to write those 20 numbers down on your activity sheet. Okay, so I'll press enter 20 times. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I'm going to write all those 20 numbers down. Now I know I went through those quickly, but what you're going to do is you're going to write those 20 numbers down in one of your lists. Okay, and then you're going to do that again. You're going to do it a total of 10 times. Okay, so you're going to have 10 lists of 20 numbers. Then I want you to look and see how often in a group of 20 people did you have a matching birthday. Did it happen 4 out of 10 times, 5 out of 10 times, 6 out of 10 times? And we'll use that as sort of an estimate of, what's the probability that in a group of 20 people we'll have a matching birthday. And we'll put our heads together and see if we can come up with a different estimate after that one. Okay, so those will be the 2 simulations. The third one, we go and do 30 people. With the way this calculator is not set up to automatically give you the 30, it's going to take us a little too long. So let's just do the first simulation where you see how many people did it take entering the room until somebody's birthday match. And the second one here, we're going to do rooms of 20 people. Okay, everybody in your team is going to do 10 different rooms, and then you're going to estimate the probability from that. Okay.